Alright, C495. Let's move on to the foundation design. Alright, assume every team finish your electoral system and member sizing. So in the previous video, we talked about the some construction sequence analysis. So I'm just showing you that line, that load, but this is using auto sequence analysis and showing you again for reminder actual force diagram. So basically the building is constructed every floor, right? For time computation time saving, I set it up 2 floors, every 2 floor constructed, and then that load self-weight is assigned. So you see that the column actual force gradually increase. All right, so what I'm gonna show you in this video, I'm gonna just show you that how to create the mat or foundation elements. And luckily, most up to date ETABS Ultimate version has the SAFE the features. We used to use the SAFE software for concrete slab design and foundation design, but now we don't have to move back and forth, back and forth. So here, make sure I'm gonna show you. Once you run the model, the we should be should have all the column reaction and wall reaction right at the boundary condition. Let me just show you that limits all the base story base, so you should be able to get all the vertical reactions. Also, X and Y component as well, right? So all the SDL and live roads and wind loads, total 12 wind load cases, the column and wall reaction is there. So I'm going to show you how to start up to create the foundation system. All right. Before we move into the foundation system, I want to make sure that we are at the foundation system design that we're going to talk about in general. And for this project, that we try to use a shallow foundation, which is we call mat foundation. And in order to do that, the mat, which is just sitting on the soil or rock, especially tall buildings, should be rested on the good soil. Here, I try to show you that soil is about continuous spring, right? So we needed some modulus of a rupture. Typically, geotech engineering book or geotech engineer provide this modulus of subgrade, which I just show you the example of the modulus of subgrade. That the number based upon some safety factor and allowable bearing based upon allowable bearing capacity. This is from the book, geotech book I grabbed. But typically, geotech engineer from their boarding test and they provide those information. So here, okay, we'll keep this modulus of subgrade reaction case spring. We're gonna use this number. Let's say maybe we can use 480. All right, so going back to the ETABS. So what we're gonna do, we're gonna create section properties for mat foundation. Mat, let's say 1696, and the concrete strength maybe 5,000 or 6,000. These days we still can use high strength concrete, but I'll keep it with the 5,000, and I'll choose a mat property type, and then thickness 96. inches. Okay, so this is material properties, section properties. I'm gonna use it, and now I'm gonna draw and pick the section property mat 96 by clicking, and I'm gonna draw the mat. But thing is, you should notice that the column is right there, sitting on the edge. So physically, we cannot do that. So we're gonna expand. Let's say 60 inches roughly. So the mat is kind of slightly bigger, enlarged to cover the column location. Okay, I'm gonna save it. All right, so we just drew the geometry. Okay, right there. Uh, and I'm gonna show you the extrusion. Right, extrusion is over there. All right, now before we just assume every column and wall at the base of the column and wall, we put the boundary condition. But now that we need to adjust the boundary condition, so all the vertical boundary condition, we're gonna remove it. Instead, we're gonna use a vertical spring constant. Assume that the soil, the mat is resting on the soil or rock. So what we need to do is we need to define the boundary condition. In this case, we're going to use a spring constant, spring, area spring, and we're going to define same thing. This case is now inches, so 480. So this case is only 480 cubic soil or rock. This case is we only allow for now assign the vertical spring constant for 80 divided by 12. So this is the first spring constant I'm gonna use. At this point, I don't know. I don't have information about spring constant X and Y, which is based upon soil passive stiffness. But I'll just restrain, pin it, so that I'm gonna restrict the mat foundation movement in X and Y. Okay, so I'm gonna click the mat, assign, and here's area spring. So I'm gonna apply the area spring, right? Okay. So since this building at this point doesn't have a boundary condition, as I said, I'm gonna click, and so that the building should not move. I'm gonna assign XY translation, so the mat basically doesn't move. It, this is mostly equivalent to our pin connections, because we assign, since I have a big mat, right? I have only 4 nodes. I vertically using spring constant instead of pin, vertical pin, and assign the vertical spring, and also restrain X and Y. So I think this model is ready to run. So let me create, save as the 4, model 4, and the mat. So I'm gonna run the model.